Welcome to Recon Walls video tutorial series. In this video, I will explain how to interpret your results for a GeoGrid reinforced wall analysis within Recon Wall 4.0. Now that you have completed your inputs for project information, section information, geometry, and soils, you are ready to analyze your GeoGrid reinforced wall section. If you are not prompted from the project information screen to select a primary GeoGrid, you will want to do that on the GeoGrid properties screen prior to proceeding. In some cases, you may want to review some of the other information found on the factors of safety and GeoGrid properties screens, but in general, the default values and information contained on these screens will be appropriate for your analysis. To complete your reinforced wall analysis, click Reinforce Design from the side menu located below Calculate New Design. Once you have done so, you should now see a table of results in the upper left corner, a graphic showing your wall section in the upper right corner, and a summary of your results, including the calculated factors of safety in the lower right corner. It should be noted that the AASHTO LRFD design methodology varies in its analysis approach as compared to the NCMA and AASHTO 2002. As such, the results table when using LRFD will look slightly different than that displayed for NCMA and AASHTO 2002. First, let's take a look at the results table for an NCMA or AASHTO 2002 analysis. The table displayed provides a summary of the analysis, including grid lengths by elevation, forces, and overall results. Going from left to right in the table, the first column is the height. The height is the distance to the specific GeoGrid layer. This distance is measured above the leveling pad. The next column is length. This is the determined required length of the GeoGrid reinforcement. After length is GeoGrid, which is just the type of GeoGrid that was used in the analysis. The next column is T-allow. This column displays the allowable tension that was calculated for the GeoGrid. The next three columns within the table contain the lateral forces due to earth pressure and surcharge loading. The next column is labeled Tmax. This is the maximum grid tension and the sum of the earth pressure and surcharge forces. The next column is labeled FS-STR. This is the factor of safety for strength of the grids. Next is TAL-CN. This is the allowable tension in the grid connection. The column labeled FS-PK-CN is the factor of safety for connection strength of the grids. The next column, labeled FS-PO, is the factor of safety against pullout. The next column is labeled FS-SLDG. This is the factor of safety against sliding calculated at each GeoGrid layer. Additionally, the factor of safety for sliding of the mass against the foundation soils is shown in the brackets next to the lowest grid layer in the table. The final column in the table is grid embed. This is the embedment length of the GeoGrid beyond the failure plane. Now let's take a look at a results table for an LRFD analysis. Similar to the previous, the table provides a summary of the analysis including grid lengths, forces, and results. The first four columns of the table are the same as previously described, with grid length, elevation, and type. Where the table starts to differ is in the forces. The forces shown in the table have load factors applied as compared to the service loads shown in the NCMA and AASHTO 2002 table. Also, in lieu of a factor of safety approach, which is determined by dividing the resisting force by the driving force, LRFD uses a capacity to demand ratio which must be greater than 1.0. The capacity to demand ratio is shown for grid strength, connection, pullout, and overall sliding. Above the results table, there are three tabs. By clicking on the other tabs, you can bring up additional tables which will give you more information about your analyzed section and some of the forces that have been calculated. For additional information on either of these tables, please refer to the Help menu. In some cases, after clicking Reinforce Design, values within the table will be highlighted in red. With each section that is analyzed, the software returns the most efficient layout based upon your inputs and GeoGrid properties. If you are seeing red highlighted cells, This is generally an indication that you need stronger, longer, or more intermediate grids. To use stronger grids in your analysis, return to the GeoGrid Properties screen. From the Primary Grid drop-down menu, select a stronger grid type and then re-click Reinforce Design. You may have to complete this process a couple times to find the proper grid type for your analysis. Depending on your conditions, you may need to modify your grids to something other than what the software has returned. A number of modifications can be completed, including changing the grid lengths, moving the grid layers up and down, and inserting or deleting grid layers. To increase or decrease the length of a grid layer, click on the ID of the grid layer that you wish to modify. Near the bottom of the screen, there are several buttons. You can click on Shorten or Lengthen to modify the grid length accordingly. Similarly, you can move the grids up and down in elevation by using the up and down buttons. The All Same Length button will modify the length of all grids above the layer in which you have currently selected. By using the Insert and Delete buttons on your keyboard, you can add or remove GeoGrid layers from your section. As you make modifications to your grid layers, the calculations and results will update automatically, showing you the effects of your changes. Once you have reviewed and are satisfied with your results, you may print the calculations for additional review of the analysis or for your record. Recon Wall has two options for printing: the short printout, which is just a summary of the results, or the long printout, which is a full version of the calculations completed. Recon recommends saving a PDF copy of at least the short printout along with the saved software file for future reference. Well, thanks for watching this video tutorial on interpreting your results for reinforced walls in Recon Wall 4.0. If you have additional questions regarding your reinforced wall analysis, please refer to the software help menu or contact us directly and we will be glad to help you out.